Good evening friends. Now we are going to start with another topic, optimization of cropping pattern using modified linear programming method. Irrigates an area of 1,04,476 hectares in Nagpur and Bandar districts of Maharashtra. Presence of the storage cum diversion dam. So in this case we have used the hydrological data. The data is collected from the 7 railway stations from Chindwada, Sunardev, Shivni, Amarwada, Tamir, Mukhed, Developar. The available hydrological data is composed of rainfall data and the gauge data. The rainfall and runoff correlation. Here we have generated 3 mathematical models for the runoffs. So polynomial curve fitting between the two variables, rainfall and runoff. The first degree equation, higher order equation and the Thomas firing models we have used. Now the polynomial curve fitting for two variables, that is the second degree equation, that is the slightly the form of quadratic equation, that is y equal to minus 21.0713 plus 1.1087 plus 0.003 x squared. Here y is the annual runoff 1000 million cubic feet and x is equal to annual rainfall and in inches. The units are old because we have obtained this rainfall series from the year 1914 to 19 for 46 years. So therefore it is used in the British system. Now then we have modified this, all the converted in SI units, and we have obtained the first equation as y is equal to 901.6748 plus 24.696x. Here y is the monsoon including 5% post monsoon flow in million meter and weighted monsoon rainfall centimeter. The correlation coefficient is 0.88. Another Thomas firing model also we have used here. The general formula is given here, where Qi and Qi plus 1 are the generated value of the discharges during I and I plus 1. Qj and Qj plus 1, they are the observed mean monthly discharges during the jth and j plus 1 months respectively. Vj is the regression coefficient, Z1 is the random normal deviate with 0 mean and the unit variance. Sj plus 1 is the standard deviation of the j plus 1 month, and the Rj is the correlation coefficient between jth and j plus 1 month. Procedure of the Thomas firing model. Let us consider this n number of years of data record for month j is equal to 1 to 12 of the year. The number of years nj in the out of n, capital N, for which the flow was recorded. Let Tj is equal to Nj upon capital N. Calculate the mean monthly flows and the variance of the flows for each month j. Fit the Thomas firing model to those successive pairs of the month for which the flow data are available. Generate the synthetic sequence of the monthly flows as follows. For the month j, choose the pseudo number n rectangularly distributed between 0 and 1. If the number is less than 3j but greater than 0, then the flow will occur. Otherwise, the flow will not occur. If no flow is occur in the month of j, repeat the procedure for j plus 1. If the flow is occurring in the month j, it is first month of the year for which the flow is to be occurred. Select a pseudo random number, random normal deviate for distribution with mean and variance equal to the mean monthly flow and the variance of flow for month j. If the flow is occurred in the month j and the flow occurred in the month j minus 1, use the regression equation for the Thomas firing model to obtain the flow for the month j. These are the runoff series that are for 80 years we have obtained. The rainfalls are given in centimeters on abscissa, and ordinate they are the runoffs expressed in million meter cube. Red line indicates the first degree equation, green line indicates the runoffs obtained by using second degree equation, and the black line they are runoffs obtained by the Thomas firing model. These are the plots of the first degree curve and the second degree curve for 80 years. The runoff on the ordinates and rainfalls are on abscissa. Red color indicates the runoff using first degree equations, and the black color indicates the runoffs obtained by using second degree equations. So mathematical model we have designed for this uh, known as modified linear programming method, that Yg is the annual yield uh, in kilogram per hectare for the jeth crop during any kharif, rabi or hot weather season. Pj is the price in rupees, kg in kg corresponding to jeth crop. Aj is the command area under the jeth crop. Then the annual return is equal to j equal to j yj into pj into aj, where j is equal to 1, 2, 3, 4 up to j. According to the guidelines of laid down by the Central Water Commission, New Delhi, providing the technical clearance to some medium irrigation projects, annual turn receipt is taken as the 30% of annual product expenses, while annual product expenses are taken as 10% of the total value of annual farm produce. Therefore, the annual farm expenses is equal to 0.1 into equation number 2. Hence, the annual turn receipt is obtained as J summation of j equal to j into 0.03 into yj into pj into aj. Therefore, the gross annual benefits, they are j equal to 1 summation of up to j 1.03 into yj into j into aj. That is equal to uh, j equal to 1 summation up to j 1.03 wj minus aj, where wj is equal to yj minus pj. So j equal to 1 up to summation of j in the bracket sj plus mj into aj. Now we are going for the expenses. So sj is the cost of the seeds per hectare and mg is the cost of fertilizer per hectare under the j crop. Considering the labor charges and all other expenses, annual expenditure, the total expenditure incurred of the seeds, fertilizer, plant production, water charges, drainage of land, and other miscellaneous expenses like land rent, cash, share rent, depreciation of implements used in the agriculture and the product. Therefore, the annual expenditure is expenses as 17.7% of WJ as per the guidelines of CWC New Delhi. So the net benefits will be 1.03 minus 1.03 WJ minus SJ minus FJ minus 0.0177 of WJ into AJ, and that is equal to 0.853 WJ minus EJ into AJ. So NBJ minus AJ, where EJ is equal to SJ plus FJ, that is cost of seeds and cost of fertilizers. NBJ is equal to 0.853 of WJ minus EJ. So therefore, the annual benefits in rupees per hectare under of the jet crop will be equal to J, that is maximization of J objective function. So summation of NBJ, that is net benefit of the J crop up into area under the J crop, where J is equal to 1 to 3 up to J. 18 crops we have considered here. NBJ is equal to net benefits in rupees per hectare of the J crop, and AJ is the command area in hectares under the J crop. The objective function is subjected to constraint number 1, availability of water resources and water requirements of the crops, that is the total water demand during the base period of the crops for their cultivation should not exceed the monthly available water from the reservoirs. So therefore, this is the uh, area and water requirements by the jade crop, and area under jade crop. This must be equal to, it must be less than or equal to the water available in that month, where I expresses for the month and J expresses for the crop. Then the second concept is the land and the crop area. Total area under the crops during the every month should not exceed the total available irrigable command area. So that is AJ must be less than the TA, that is total command area. Then the third constraint is the soil and agricultural limits on the crop. The soil and agricultural constraints are the upper and lower limits of the area under the crops, which are to be cultivated depending upon the factors like soil type, fertility, field capacity, climatic conditions, government policies, socio-economic returns, uh, of the agriculture and zone or command area. So upper limit is AJ is less than or equal to CUJ and the lower limit is AJ greater than CLJ. So where CUJ is the maximum permissible jade crop cultivation area and CLJ is the minimum area of the jade crop which is to be protected during the critical year. And AJ is the area under the existing of standing jade crop during the critical year. So these are the results obtained from the 50% reliable flow or the 50% dependable yield. So here you will find the sugar cane. When the rainfall is high, then it is possible to take the such sugar cane crop where the duty is more. Then the soybean, then cotton, chilies, oil seeds, pulses, bajra, maize, chilies and vegetables. They are giving this benefit in terms of the crop returns. This is the result for the 65% reliable flow or the dependable. So here also you will find the different crops which are shown in the brown colors. Soybean, wheat, gram, then cotton constitutes the maximum benefits here. Then relatively, then vegetable and potatoes, oil, seeds and the pulses. So this is the normal year of rainfall. We consider that is at 75% dependable yield, also 75% reliable. So in this case, soybean, wheat, cotton, veg potatoes, oil seeds, pulses, soybean, chilies, veg potatoes. These are the cropping pattern are obtained at 75% reliable. Then this is the 90% dependable yield or the reliable flow. We consider that the critical year of rainfall. Below that, we consider it a drought prone year. So in this case, the wheat, gram, cotton, uh, veg potatoes, oil seeds, bajra, soybean, groundnut, chili, veg potatoes, they are the recommended crops during such critical year of rainfall. So the benefits obtained from the different yields are expressed in terms of this graph. Then this is the composition of the benefits from the 50% dependable yield. So cotton constitutes maximum 44% and then followed by 80% by pulses and then by other crops. Then composition of crops at 65%. Again cotton constitutes 41%. Then this is the composition of benefits of 75% reliable flow. Here also pulses constitute maximum benefits, then cotton followed by cotton 30% and the remaining crops. And this is the 90% dependable yield. Here oil seeds, vegetables, they constitute more than the other crops. Thank you.